Isso. Tá bom, eu vou começar de novo para quem está online. Então, eu queria agradecer a presença de vocês e, particularmente, a presença do professor Ralph Levinson, que abriu um pequeno espaço na sua viagem de férias para o Brasil. Então, ele juntou... ele tem amigos no Brasil há muito tempo, então ele vem com alguma frequência. E quando eu o convidei, ele me deu essa possibilidade, que ele estaria no Brasil, então ele poderia abrir essa possibilidade. Então, para quem não conhece o professor Ralph Levinson, ele é professor do University College London, que costumava ser um dos institutos da University of London University, e que era um Institute of Education, e que virou, ele estava me explicando, que virou uma universidade. Tá? O professor Levinson é uma pessoa conhecida na área de educação científica, né, na pesquisa em educação científica. Ele tem uma quantidade enorme de trabalhos sobre tomada de decisão, risco, sobre educação em meio ambiente, tem vários, e o trabalho mais recente que ele desenvolve é esse trabalho que ele vai apresentar, que chama-se Paris Project, que ele vai explicar para vocês, eu não vou adiantar, mas é um projeto que envolve o que a gente poderia chamar uma pré-iniciação científica, mas o interessante é ver o que é essa pré-iniciação científica na perspectiva que ele vai apresentar, tá bom? O professor Levinson vai fazer, logicamente, a apresentação em inglês, né? Ele falou que o português dele ainda não é suficiente para isso, mas ele fala muito pausadamente, muito claro, então acho que não vai ter muita dificuldade para vocês entenderem. E no momento das perguntas, não fiquem com problema, né? Na hora as pessoas que estão aqui vão ajudar, tanto na tradução da pergunta, se for o caso, e da resposta. Tá bom? Few words in English. I'd like to ask you thank you to be here, to save a part of your trip, personal trip, tourist in Brazil, and to come to see us, to know our university 20 years after. He was here 20 years ago, and offer us your speech about the project that seems very interesting. Thank you very much. This is your moment. Thank you.
Muito obrigado, Mauricio. Desculpa-me por falar em inglês. Falar lento. I was giving a talk in a seminar about 10, 15 years ago in Santa Catarina. And I worked with my friend Arden Silberstein at the time, who was to help me give the seminar in Portuguese. And as I was giving the seminar, the man next to me, the chair of the seminar, said, "Ralph, gostamos você falar em português, mas entendamos, we understand, o inglês melhor que o português. So, I will spare you my Portuguese and I'll speak slowly in English. I think it will be much better. I've been invited to talk about the Paris project, which was a European project with 17 different European countries. I was involved in devising the framework for the project. Paris means just solely the promotion of attainment in responsible research and innovation in science education. RRI, Responsible Research and Innovation, which you can see in the Paris name, is a very big project in the European community to promote research and science which is for people and with people. And therefore it has an important role in science education. But before I discuss Paris, I'll want to discuss some theoretical ideas first, and generally about science, and then show their relevance to Paris. So, We have many issues in developments in technology which are not always particularly good. And you can see some of the aspects there, that sometimes science and technology can be used to exploit people. It's part of a role of exploitation, as well as many promising things. The question is, how can we promote, if you like, justice and better things in science and technology, rather than the kind of things we've shown here? And I want to just start off with a remark. You all may be aware of Leo Tolstoy, his novels War and Peace and Anna Karenina. And Tolstoy said something which I think we still deal with today. Science is meaningless because it gives no answers to our question. The only question important to us, what should we do and how shall we live? And I think, although I disagree with some of that, and I'll show you why, nonetheless, I think it's a question young people face a lot, because they might say, so what, the atomic number of hydrogen is 1? Discuss, well, but what's it mean? What does it mean to us as people? What does it say about things like love and death and and emotions and our spirituality? Science has nothing to say about that. And I want to question that. And I just want to show some of the historical problems we faced here. Here is a painting on the left-hand side by the poet and painter William Blake. William Blake was a romanticist, a romantic, and he has a very important role in English literature. And this is a portrait of Newton, of Isaac Newton. Now, I can assure you, Newton did wear clothes. Newton didn't go around naked. But it shows Newton's the problem with science, that Newton is completely focused on measuring things. He's not looking around, he's measuring the world. In other words, he's seen almost as an extreme positivist. And in fact, that painting is replicated in a bronze sculpture outside the British Library by the architect Edoardo Perlozzi. And it still reflects this idea of science as being a focus on measuring rather than looking about and appreciating the world. This is a famous painting in the National Gallery in London. I'm sorry to be so centred on London and Britain at the moment, in the UK. But it's a painting in the made in the end, towards the end of the 18th century, by a painter called Joseph Wright of Derby. And Joseph Wright was very interested in science. And in this picture, he's showing a scientist who has developed a vacuum pump. So it's a pump to get rid of air. And this was a very exciting development because, as you know, you can do a lot with vacuums. And he was demonstrating this, and you may be able to see this in the pump itself. I'll just go up. There's the pump. And near the top of the pump is a bird, is a cockatoo, is a bird. And the scientist is trying to demonstrate that if we can remove air, the vacuum from the pump, the bird will die, right? So you're showing you can get a vacuum, the bird will die. And the two central figures here are this little girl and her older sister. And of course they're presenting, this is terrible, this is a horrible thing to do. And it's reflecting an essential tension in science of the power of science to do things, but also it can have quite shocking consequences. And I think that is still something that we live with today, that we're dealing with today. And we have the issue of, where does science go? Now in Britain, and maybe this is the same in Brazil, I don't know. But in Britain we have a tension between those educators who want to introduce socio-scientific issues into the curriculum. so where science and society are central to what we talk about, and those who want to keep society completely out of science. Social issues don't have anything to do with science. They're a different kind of discourse. Science, facts and values are not interrelated. They're a dichotomy. And this is a battle. This is a central source of tension in the curriculum. And at the moment, those who prioritise science, privilege science, the core science, are, I would say, winning the battle. And here you have the UK government curriculum advisor saying, we need to keep the national curriculum up to date with topical issues, fine, society, but oxidation and gravity don't date. We are taking it back to the core ideas. And in fact, I have to say, there are many science teachers who prefer that way because they say we know science and it's very difficult to talk about social issues. Our expertise is in teaching science. So it has some acceptance within the science teaching community in the UK. And in many ways, this is associated, I would say, with what I would say is a global agenda of neoliberalism. We have, for example, you'll be aware of the PISA tests, and there's a great national debate. If the UK comes low down in the PISA table, then we're not teaching science well enough. The teachers must do better and teach more science. And it's associated with globalization, with the STEM agenda, the science, technology, engineering and mathematics, and an economic and national competitiveness. And the result is often that because the curriculum is so directed towards this core remembering science, that the phenomenon of presentism exists, if you see at the bottom. That is a persistent focus on short-term measurable outcomes. And these measurable outcomes are mainly through examinations. So the pressure is on students to learn for the examination and often not to understand some of the broader reasons. Now, I just want to go back to this idea of science and values, that science is core. Because what I would argue is this was an Enlightenment project, that it stemmed from people like Descartes, that science was the rational way of apprehending the universe. But in fact, and it was divorced from values and emotions. But in fact, I want to argue that the history of science shows that this isn't the case at all. For example, if you're an evolutionary biologist, evolutionary biologists often argue, and I've seen this very much present in school science discussions, that evolution is not teleological. In other words, evolution can have no purpose. Evolution is random. In a case, natural selection occurs. It's about adaptation, although I would argue adaptation itself is a purpose. But the idea is that evolution is non-teleological, it's random, the outcomes are not discernible in advance. But look at Charles Darwin and natural selection. In The Origin of the Species, Darwin says, and this is in The Origin of the Species, you can read it, natural selection works solely by and for the good of each being. So good is a value term, the good of each being. All corporeal, that's bodily, and mental endowments will tend to progress towards perfection. Now, if that's not a statement of purpose, I don't know what is. In other words, there was a strong teleological element to Darwin's thinking, and I think we need to acknowledge this. Let's look at Newton. Newton is the apotheosis of determinism, that the world works almost mechanistically. But look at Newton. This is a statement from a letter he wrote to an English colleague, 1693. So gravity may put planets into motion. I'm sorry, it's in Old English, so I'll read it in contemporary English. Gravity may put planets into motion, but without divine power, it could never put them into such a circulating motion as they have about the sun. And therefore, for this, as well as other reasons, I am compelled to ascribe a frame of this system to an intelligent agent, right? So Newton could not be a Newtonian today. Newton would be seen as, what? This is mad. This is crazy. So I think to understand science in schools, it's ignoring very much the way science has developed historically. And I don't think this is to the benefit of students who really want to understand what the project of science is about. And I want to go back onto this fact student. In England, we have a big thing. There are facts and there are opinions. There are facts and there are values. And here is a discussion between a teacher I heard in a class of small children. All right, class, in this lesson, we are going to focus on the differences between fact, that is what is, and opinion. Can someone give me an example of a fact? Pupil, school dinners are rubbish. That is an opinion, not a fact, says a teacher. Pupil, no, it's a fact. And I think this is important, that the dichotomy between facts and values is not necessarily a clear one. For example, if I say copper is a better conductor of electricity than plastic, I'm making some kind of value statement about that. Yes, copper is a good conductor, plastic is not a good conductor, copper is a better conductor. I'm making a statement of preference. Facts and values are not totally independent of each other. So I want to sort of, by looking at a theory which has been influencing me, I think, a lot in my thinking in terms of this, by a philosopher called Roy Bhaskar. He was an Anglo-Indian philosopher. And he presents the question, what must the world be like for science to be possible? And I want to just focus on this for a moment to develop eventually the idea behind Paris. I want to start with this is an object. You'll find it in the castle in Seville in southern Spain. It's something that impressed me very much. And you may know that Spain was ruled by the Moors who were essentially Islamic. From the 8th century, for about 800 years, Spain was under the domination of the Moors who came from North Africa. And the Moors were mathematicians. They were interested in mathematics and they were interested in patterns. And this is a beautiful pattern which essentially say, well, why are people interested in patterns? Why are mathematics and patterns so important to us? And we see patterns a lot in nature. We can recognize in nature many of these patterns. This is a sunflower. You see the sunflower seeds, and you can calculate from this the Fibonacci sequence that there's a pattern to the way organic things are arranged. We can have a look. There is a pattern. I'm looking at the hexagon. There I'm taking an example of a football net, a soccer net, a goal, and then the net behind it. I was going to refer to, this might be the Brazilian goalkeeper in the Brazil-Germany match, so I'll be careful about this. But maybe here is a goal going in, ball going in. But I want to focus on the shape of the net, the structural shape, why we're using hexagons. But hexagons are used all over the place in nature. Here is a honeycomb cell. Here's a water and soap, soap on top, which forms into hexagons, a soap film. These are limestone rocks which have crystallized into hexagons in the west of Scotland. And these find hexagons, of course, very much in organic compounds, living compounds. There are patterns. Nature seems to exist in patterns. We have, obviously, the pattern here, the periodic table. We know columns of the periodic table, so the 1, 2, and 3 and 4, so on, that the elements there have similar properties. As we go across the periodic table, they change very gradually. There is a pattern, it seems, to the way the world is organized. And so it raises the question of how can we, some basic foundational questions, what can we say about the world? To have science, we have to have a world which is describable. So we ask ourselves, is the world organized? Or do we organize the world? Do these patterns actually exist? Or do we organize them into patterns so we can make sense of the world? And is nature independent of mind? Of the nature we have, the world we look at, is it independent of the way we think? Or do we organize the world? Is there a sense in which the mind organizes nature? And I want to go to just to show that actually these questions are almost eternal. They have been going on forever. And they're going on today, and they were going on in classical Greece, and they were going on long before classical Greece, and they were going on in all sorts of cultures in the world, this question. And I want to take a painting. This is a painting by the Renaissance painter Raphael. And some of you may have seen it, may recognize it. It's called The School of Philosophers. And I want to focus on the two men who were entering the School of Philosophers. The one in blue and the one in red. And I'll just focus on them a little bit more. And these two men are represented. The one in blue is Aristotle, and the one in red is Plato. Plato and Aristotle are walking into the School of Philosophers. Now, the really important thing to notice here is their hand movement, their hands. Plato's hand is going like this. Aristotle's hand is going like that. And this reflects a complete difference that we have in the world of science thinking. Plato is pointing to the heavens, to the ideal forms that happen beyond Earth in the planets and the sky and the way the planets circulate. And he's saying, this is the ideal. This is where we need to look to understand nature beyond Earth. We need to look at the ideal forms. And Aristotle is saying, Aristotle is the empiricist, is empirical. Aristotle is saying, no, we need to look here at Earth with all its messiness to see how science operates. And this, I would argue, is a real problem we have in teaching and learning about science. And I'll come to show how it informs Paris in a moment. So I want to look at some basic ideas of what I call the critical realist approach, which is basically a philosophy developed by Bhaskar, although he developed this a lot. And I want to look particularly at a particular aspect of what I would call critical realism. And in critical realism, we need to what Bhaskar would argue, what critical realists argue, is there is a world, a real world. We can divide almost, the modernist point is we can't talk about an independent reality because we can never know an independent reality. We can only discuss what people say about the world. An extreme naive realist will say there is a world out there when we will eventually discover it. And critical realism takes a realist ontology. There is a world out there, but actually it's epistemologically relative. In other words, we can know the world, we can learn about the world, but we can never know it completely. We study the world through science, but we'll always progress, we'll always find other things. There is something there, not like the postmodernists argue that it's just how people talk. There is something there, but we can't know it completely. But on the other hand, we can validate that knowledge. We can say that some knowledge about the world is better and more valid than other kinds of knowledge. So we have a realistic ontology, an ontological realism, epistemological relativism. In other words, there are different ways of knowing about the world. Some ways are better than others. And this also includes different ways, not only scientific ways, but social ways, philosophical ways of knowing about the world. But there are means of validating and judging this knowledge. And it's what is called the Holy Trinity of critical realism, bizarrely. Bhaskar, I believe, was an atheist, so it's strange to have the Holy Trinity of critical realism. But nonetheless, these are the main points: ontological realism, fallible relativism, epistemological relativism, and validation, judgmental rationality. So, the important assumptions of critical realism are mainly moved towards the Aristotelian way of thinking. So, Bhaskar argues, critical realists, I would say, would argue that experiments are often carried out in highly controlled conditions. They're not open. They're enclosed systems. And I don't know about you, but I remember learning at school when I was 13 or 14 the law of falling bodies, right? So you had a body, you dropped a heavy mass and a feather, and they would reach the ground at the same time. That was the law of falling bodies. Well, they never reached the ground at the same time. The feather always landed last. But the teacher said, no, really, they should reach the ground at the same time. And we accepted that. Okay, we accepted that, but it was complete nonsense. We could see 100 times out of 100, this was not true. Of course, it's true in a vacuum. And if you're out in, if you're in conditions in space, like in Plato, the ideal conditions, that's true. But it wasn't true on planet Earth. It simply wasn't true. Another thing I'm going to talk about is water. We all learn, I remember philosophers saying the other day, the one definite thing we can say is water is H2O. It's not, right? Water is anything but H2O. And we'll go and discuss this in a moment. So what critical realists argue is that objects, things have causal powers. In other words, there is an attraction from heavy bodies like the Earth towards objects. The Earth has a causal power to attract objects, but air, the flow of air, also has the causal power to interfere with that fall. So we need to learn about the cause, what objects can do, what things can do, rather than start from these universal laws. We have the thing if acid and metals. Acid has the causal power to dissolve metals, but we'll know this when we actually add the metal to the power. It doesn't do it until the metal is actually added. It has a potential to dissolve metals. One way to think about this also is if you think of a cat. If you think of a cat fast asleep, it's sun, the cat is fast asleep, it's a sunny day, I'll go to sleep. And whenever you see a cat, you think it's totally asleep, it's in motion, it's motionless, maybe even dead, or you can see it breathing. And then someone rings a bell, and the cat goes, what? Straight away, okay? And what it does, the cat, when we see the cat, we don't know anything about its ability to jump. It's when we ring the bell that it jumps. So it has this potential, but this potential isn't always realized. It has particular circumstances in which that happens. And critical realists would also argue there's no dichotomy between facts and values. Facts can inform values, and values can inform facts. So just to reach, we have this, classical experiment you may remember, you may have been told about. I think it's completely mythical. Galileo stands on top of the Tower of Pisa and drops some objects, and whoa, they reach the ground at the same time. Of course they don't. It's nonsense. But it's a myth. There's also the myth of, you may have heard as students, Isaac Newton sitting under an apple tree. Isaac Newton is 14 years old. He's sitting under an apple tree. An apple drops, and he says, gravity. I mean, this is so ridiculous, but nonetheless, we learnt this in school as if it was a truth, as if you could just see things happening and therefore infer the world from them. And this is water. Is water really H2O? It's not. Water is never H2O except in ideal conditions, and it's never H2O because H2O describes the relationship between the number of hydrogen atoms and oxygen atoms. But in fact, oxygen is in the air, water is in the air, it dissolves oxygen. That's why fish can live in water and plant life. It dissolves oxygen, it dissolves carbon dioxide, it has lots of metals in it. So if we analyse some water from various parts, we would see it's not H2O. It's only H2O when it's made in ideal conditions in a vacuum. But the world is not ideal. And these are, just want to talk about, discuss, before I go on, the dimensions of critical realism. So we have what we call three domains. The empirical domain, the world we see and observe. And if we take an example here of a polluted pond, or we can observe a pond as polluted. We smell it, we see experience its decay. But to actuate that, we need certain conditions need to happen. Where the water needs to lack oxygen, and there may be reasons why the water lacks oxygen. So we need people maybe who throw things into the pond. So there's certain events which happen which actuate that decay of the pond. And the real domain is the point. The real domain is the explanation, both scientific, social, and otherwise, the explanations which explain why the pond is polluted. But we can't necessarily see those explanations. Those explanations are hidden, but they're nonetheless real. They're as real as atoms and molecules and so on, which we can't see, but they explain so much of the world around us. So we have three domains: the real, the causal, the real, which is the causal, the mechanisms, the actual domain, and the empirical domain. So this is just a resume of these things. And I just want to, before to finish off, to explain critical realism, the point about stratification and emergence. Because critical realists argue that you can explain the world through different disciplines. So we have, if you like, at the base, physico-chemical ways of explaining nature. And then we have biological, psychological, social, and economic on top of that. If we think of something like, say, photosynthesis, which is we talk about the reactions, chemical reactions in photosynthesis, but we very rarely talk about quantum effects of photosynthesis. We talk about photosynthesis at broadly a biological and sometimes chemical level. The disciplines of biology and physics and chemistry work in quite different ways. Biologists often ask the question, what are these things for? Whereas chemists, for example, will ask the question, what are they made of? So organic chemists, and for instance, organic chemists might be quite different from, say, microbiologists. Although they work in similar fields, they're asking different kinds of questions. And a psychologist, for example, the psychological, let's go back to the Brazil-Germany match. I just want to be annoying for the moment, okay? We say, why do the Brazilian players play so badly in that match? And we might say there were psychological factors. They were just not ready for it. Of course, the psychological factors are underpinned by biological factors, and these are underpinned by physico-chemical things, but they don't determine how you play. Of course, they are there, but there are different things which explain. The world is stratified. Let me try and explain this, give a simple example and come back to water. Let's say, for example, that water is H2o. Water is made from hydrogen and oxygen. Water at room temperature is a liquid. It's a liquid at room temperature. Its formula is H2o. If we look at oxygen and hydrogen, they're gases at room temperature. Oxygen relights a glowing splint. It has different properties. Hydrogen is inflammable, but water douses flames. Oxygen and hydrogen non-polar chemically. Water is polar. In other words, water has completely different properties from its constituent elements. It's made of those things, but it emerges as a different component, okay? So you've got these constituent elements, but they're different in properties from water. And critical realists would argue the world is organized into those distinct kinds of disciplines. So I want to just, before I go to say, what are the implications for teaching? And I'll say the implications for teaching are this, that we need to distinguish between scientific concepts and events. Often in science we teach from the concept, but I would argue it may be better to take an event and start from that and see how the concepts work to explain the event. that events have multiple causes. They're not just scientific, they can be social, economic, and so on. That we need to engage with uncertainty because we live on planet Earth. Planet Earth doesn't work perfectly. And this comes into, the theme I know you've been discussing about risk, that uncertainty also underpins how we talk about risks. And I encourage students to reflect on the difference, the distinction between descriptions of the world, how we describe the world, and what the world is. What the world is and what we know about it are not necessarily the same things. And to explore different accounts, as we can see, to look at how Newton thought about the world in his time and how Newtonians think about the world today. The tension between open and closed systems, that the science we most oftenly draw upon is through closed systems, not open systems. And challenge students to think about what might be absent in scientific narratives. And here I want to go on to an example of where I think critical realism and where Paris plays an important role. Here is a young woman, she's on her cell phone and she's smiling, she's happy. She's talking to a friend, she's happy, she's brave. And the question is, I would ask Nessun, what makes that smile? What makes that smile? What are the conditions, what are the things that make that young woman smile? Well, first of all, you need a big industry, a big organisation to manufacture cell phones and to distribute them. In other words, you need an economic and social base for those things to get to people, like Samsung, the big tech organisations. So there's an economic aspect involved. I'm not a physicist, I'm sorry, but you also need to recognise that cell phones have semiconductors in them, and they work according to their chosen because of their particular properties. This is one of the metals present in cell phones, niobium. Niobium and tantalum are two of the chemical elements which are central to making semiconductors, which consists in the chips of cell phones. Now, my question is, what does that smile then have to do with the East African chimp, the East African gorilla, living in the forests of East Africa? What is the connection? Well, I can tell you she's not talking to the gorilla on the phone. There's not talking. There is, in fact, a much more insidious connection between that young woman smiling and between that gorilla living in the forests of East Africa. And it's this. This is how tantalum and niobium, the rare metals you need, are mined. They are mined, they come almost exclusively from the Democratic Republic of Congo. And they're mined in these conditions. They're mined by hand. Children are very often involved in the labour. And that is why your cell phones are so cheap, why we can afford cell phones, because this is slave labour. Okay, this is slave labour which makes these cell phones possible. And it's made possible because paramilitary groups take over the areas where these rich minerals are found, what is called coltan, where these rich minerals are found, and the people who live in those areas are expelled. And where are they expelled to? Where can they find their livelihood? Well, they move to the jungle, they move to the dense forests, where they live with the gorillas. But the only food, the only meat they have available to them is in fact the gorillas. So the gorillas are killed for bushmeat. Okay? So the gorillas are killed for bushmeat because these people they lose their homes and they move to these areas. Now, what I want to argue is that to understand the cell phone, we need to understand these diverse conditions which make something possible. Okay? There is the science, there is the economics, there is a whole range of conditions which make these things possible for us. And I would argue it's true of many other products, which are good. And this is something about the mortality rates of the Democratic Republic of Congo. Despite the fact that the world's wealth, that our cell phones, our technologies come from these minerals, it still has a very, very high mortality rate. And I want to argue that one of the problems with science, and even with socioscientific issues, and with STEM, is that it focuses on applications and risks in consumer societies, but it ignores the injustices of production, which are just as relevant to the science and technologies we have as the science and research which goes behind this. And that part of the issue will maybe to examine this problem space, the deliberation, the problem, the conflict between science as we're taught at school and the realities of the production of science and technology. So I want to argue that a very common way of seeing science in schools is what we call through a Vision 1 approach. We start from the concepts and then we learn their applications. So you start from the canonical science, the laws, the theories, and we might see how they're applied to science. Vision 1 is, let's just learn about the core concepts. Vision 2 is, let's learn about the core concepts, but contextualize them. And I want to argue that maybe we could look at this a different way. Maybe we could start from an issue or a problem, and then we can try and find solutions to that problem. The problem itself may change, but to do so, we have to think, if you like, about science on Earth. The contextualized science. How does it really operate? How does it help us to understand these events? Remember that then it's not just science, it's other concepts which help us to understand the events that happen on Earth. So the science will be contextualized, it'll be destabilized, and it will be multidisciplinary. We'll need a number of disciplines to learn about these things. And I've just quoted some of the main authors who don't necessarily talk about critical realism, but are doing similar work. Socially acute issues, Lagarde and Simoneau in France, Stepwise in Canada, Larry Bentz and Lynn Carter, and Vision 3 from Sweden, Jesper Sjöström from Sweden, who talks about these things as well. Now I want to come on to Paris. And these were the main things behind Paris, this concentric circle, that science should be responsible research and innovation. And I would argue responsible and research and innovation goes back to the kind of things we talked about with our cell phone, the social responsibility, the responsibility we have to producers, that science isn't just made to make the rich more wealthy and to impoverish the poor, that there needs to be a system of justice behind this. And indeed, the main elements of responsible research and innovation are social desirability, to make goods that society needs, ethical acceptability, that they're ethical, and that they're also sustainable. And beneath that, we need a critical citizenship. We need a citizenship who can respond to these things in a just way, and we need teachers who can teach it. And the central idea, or you can see these things, SSI, IBSE, SSIBL. I'll explain the SSIBL symbol. Means socially scientific inquiry-based learning. In other words, we're looking at how inquiry questions can drive our understanding of science and its role in society. And just to put it down, to compress it, so students start off by asking questions which they're interested in, social questions, scientific questions they're interested in. They find out, they do work, they inquire, and then they act. They do something about it. And that may lead them to ask different kinds of questions again. But they must incorporate this central idea of social desirability, goods which are important for society, ethical acceptability, and sustainability. And that's the core framework, the core model of Paris, of the core model here. So what do we mean by actions? What does it mean to act? And here are some examples. They can result, for example, in students making something, an artifact. They might lobby powerful institutions. They might put forward good reasons to powerful bodies to say, this is unjust, and why is it unjust? I want to give actually a small example here. This was before Paris, but I was talking to a principal of a school. And in the school, they had drinks which dispensed fizzy drinks, a drink machine which dispensed fizzy drinks, okay? And the role of this fizzy drink machine, of this dispenser, was to raise money to run after-school clubs for socially disadvantaged children. But some students, older students, said, fizzy drinks are not good for you. Coca-Cola, it stops you learning, it makes you hyper-excited, it gives you too much sugar. We shouldn't be selling these drinks. And the head teacher said, well, okay, I agree with you, but how else can we raise money for these after-school clubs? And he said, you find an alternative way of raising money, and then I'll put it in if it's reasonable. So the students lobbied the other students in the school. They carried out a big campaign. They used reasons, scientific reasons why dispensers were bad, and then they decided to institute soft drinks which contained less sugar, which weren't fizzy, but which students could still buy and enjoy, and that was accepted. So they learned to act politically. They learned to persuade people through information and evidence. Another act might be to generate instructional materials to help do something, promote change in school policies. I've just given an example. They might hold a forum for discussing an issue at stake, which is contentious. They might use a drama, stage a drama. They might write something influential or display posters to promote further discussion. These are the kind of things that students can do. And they're based on, I would say, for critical citizenship, to make citizenship on a number of factors. Compassion. Compassion has to be a central fact, that you feel for other people. That social justice, that securing diversity, that we recognise that the world we live in is diverse, not just with people, but with fauna, the whole range of fauna of life and even immaterial life, that the world is a diverse place for living, and that we can renew that life, we can do things to make a difference to that life. And this is based on a number of factors we need as citizens' personal awareness, how aware we are of our own actions and behaviour, local awareness, our place where we live in, the locality, how that relates to global awareness, and how we might take political action. And so, for example, let's take the mobile phone. We need mobile phones to act. Right? We need mobile phones to communicate with each other. It's almost impossible to communicate without mobile phones. But we also need to be aware of their production. Now, there may be a tension there and a conflict, but critical citizens are aware of that conflict and of the kind of action they might be taken to resolve that conflict. So I'm just taking, and this means there are different conceptions of the citizen. The citizen might be somebody who is socially responsible, or participative, or personally responsible. And let's try and identify the difference between those. A personally responsible citizen might be somebody who puts their rubbish into the recycling bin because they're told to do so, and they think that's the right thing. So they recycle. They don't have any particular ideological commitments, but they know that's the right thing to do, and so they do it. A participative citizen takes a critical approach and discusses and understands the reason for recycling, informs themselves about the reason for recycling. But a socially responsible citizen might take a much more proactive approach. They will critique recycling. They will understand reasons for and against and the politics behind recycling. They will understand its nature. They will, if necessary, lobby for more recycling schemes or whatever. And they will learn politically how to act and link with groups with similar values and interests. So we'll need to recognise how to use their knowledge to act politically, to change things. And these are some of the ideas. I'll leave this so people can look at it. I won't go. But these are the kind of skills needed for social responsibility, a knowledge of how to act, skills, values, and dispositions, having the right attitudes to act this way. I want to go on to an example we had from Paris, which we did with older students. Paris involves school students, from young school students aged 5 to 19 years old. And I want to go on to another story which students investigated. And I want to look at something they were investigating called catalytic clothing, right? Catalytic clothing. Catalytic clothing was a project between a chemist and a clothes designer. And they were able to make clothes which, beautiful clothes, really beautiful, nice clothes, which as you walked along in these clothes, purified the air, right? They purify the air. What's not to love, right? This is fantastic. You can't lose, can you? You're wearing nice clothes, and at the same time, you're cleaning the air, you're purifying the air. And part of the project was to find out, well, how can you measure this? How can you find out how many people do we need to wear these clothes to really make a difference to the environment, okay? How many? So catalytic clothing. Now, this is broadly the chemistry behind it. You have a catalyst called titanium dioxide, which you put in washing powder. And as the clothes get clean, the catalyst, which is a photocatalyst, it's activated by light, attaches itself to the fibres in the clothes, okay? And when moisture from the air hits the catalyst, it breaks down the water into radicals, into what we call hydroxyl radicals. And these radicals are very, very chemically active, and they react with pollutants in the air, particularly NOx pollutants, so nitrogen oxide pollutants from petrol and so on, and they break them down into a relatively harmless acid. Okay, so in other words, you walk along, and if it's moisture from the air, helps to knock out these pollutants, these gaseous pollutants, and you're literally purifying the air as you walk along. So the students set about measuring these things. And titanium dioxide is also used in paints. It has a lot of uses, titanium dioxide. It's a very, very useful thing. Now, one student went a bit further, and she asked the question, titanium dioxide is fantastic. You know, we can use it in clothes, it can do lots of things. Where do we get it from? Where do we get titanium dioxide from? Once she started to ask that question, different things started to happen. Because the question is, what does catalytic clothing have to do with the outbreak of Ebola virus in Sierra Leone? Remember Sierra Leone in West Africa? There was a great outbreak of Ebola virus. Many people died. There wasn't a properly functional health system, and it was terrible, terrible outbreak. People died. Well, what can catalytic clothing possibly have to do with this? Well, it has a lot to do with it. Because Sierra Leone is the richest source of rutile, which is the mineral which underpins titanium dioxide. Okay? 95% of the world's titanium dioxide comes from Sierra Leone. And the company which owns these mines is a global corporate, multinational company called Sierra Rutile. And what happens is Sierra Rutile takes over the mines, and these are mainly in a fruit farming region. And the fruit farmers have been displaced from their land so that the mining can take place. And what's more, if Sierra Rutile paid its proper taxes to the government of Sierra Leone, there will be a proper health service. But Sierra Rutile pays virtually no taxes to the Sierra Leonean government. So there is very little government funding to develop proper health services for people to act against things like Ebola. And this is a report called Not Sharing the Loot, where a lot of this information came, and this student found out a lot of the data to underpin this, which was compelling, and showed that maybe, hang on, there's a problem with catalytic clothing. Catalytic clothing doesn't come without a problem, that there is a problem to it, that we need to look at the source. If we're clearing our air in our country, in our parts of the world, but not paying attention to what's happening to the source, then we need to problematize that. And indeed, this is a graph is the amount of income, the amount of tax revenue lost by global corporates who don't pay their tax for these problems. Now, she also found, she went to the Royal Society of Chemistry, and which has a lot on titanium dioxide. And the Royal Society of Chemistry talks about the photocatalytic manufacture of titanium dioxide. And it shows a picture of a young African woman happily carrying water, which has been purified by titanium dioxide, but it doesn't say a word about the conditions under which it is manufactured. In other words, the representation of the process conceals real problems. And I would say the image is rather like a Trojan horse. You know the story of the Trojan horse in Trojan Horse? The Trojan horse comes in, looks great, but it's hiding soldiers who eventually jump out of the horse and destroy the city. We need to be aware of these kind of problems, of the more global effects of how these things act. And I just want to give an example, sorry, it's not very well put here, of another small project. I'm not saying all these projects are good, where this is not true of Brazil necessarily, although you can carry out a different experiment in Brazil, but it's certainly true of the UK, where it's cold, right? It's cold in the UK in winter. And often schools have a cold. You can sit in classrooms, there's heating, but the problems with the structure of the classroom, the children feel cold. So the children did a project to find out how can we cut the heat loss from our schools? How can we conserve fuels to stop heat being lost? So again, this was a project to help make their classrooms more congenial for learning. So the science content they had to know was about energy transfer, fuels, fuel conservation, insulation, how they could use thermal imagers, and how they could sample parts of the school to do this work. So that was the science content. Then they had to ask questions. Remember the main model, ask, what are the questions? Where does the greatest heat loss take place? What can we do about it? So these were their inquiry questions. Then they can find out, how can they measure the heat loss? Measuring heat loss, we learn, I'm thinking of things like pH. We measure, pH of acidity. We learn to measure pH with litmus paper and then with pH electronic equipment. But once, remember, students were asked to measure the pH of rivers. And of course, to measure the pH of rivers, it's not a matter of just putting your pH paper in the river. You have to know where to take your samples from, where your reliable samples come from. It's not just a matter of looking at it. In other words, you have to think about water flow, you have to think about the temperature of the water, you have to think about what the size of the samples you take. So you're really making the science work for you in particular conditions, rather than learning the concept of pH. So they had to learn how to measure heat loss, where to go and what to do, where to measure where the heat was greatest, where it was least, and what was happening, where the flow was taking place. They had to gather data, interpret that data, think about the efficacy of insulators they could use. So they could use insulators to prevent the energy flow. And research into energy conservation of buildings. So do some research and find out where is energy lost in buildings. And then they had to act. Then they had to do something about it. And this was presenting information to a democratic school council to devise ways to help the school to present this to decision makers, to take action to make the school warmer, these classrooms warmer during winter. And it's obviously socially desirable, it's good, for people to learn in good conditions, it's ethically acceptable, and it's sustainable because it's conserving fuel. It's conserving fuel for us. So these are some of the activities we could take through Sybil, preventing energy loss in our school. We talked about young people smoking. I don't know, again, the situation in Brazil, but in the UK, we have an issue particularly with young women, particularly with girls at school. Girls will go away from school during break time or lunchtime. They will find a place to smoke together, and they smoke together. And It's not so true of males, strangely enough, but it's really true of young women. Young women have a real issue of smoking, teenagers. So the question is, how can we do it? How can we discuss this with people, to talk about the benefits and dangers of smoking? Plastic waste, animal testing, cycling to school. How can we encourage people rather to take transport to cycle? What do we have to do about the roads to make them safe? How do we have to instruct people? What are the health benefits of cycling? Planning a school garden, sources of renewable energy, pesticides in food, living on plants other than earth. And I also just want to mention very briefly about renewable energy. Again, thinking about solar panels. Solar panels are fantastic. They convert light right into, rather than using fuels, fossil fuels, we can use the sun, energy from the sun. But again, one of the students found out, said, discussing solar panels, why are solar panels so cheap? And she found out that many of the solar panels are manufactured in China. And for the solar panels to work properly, they need a varnish on top of them, which doesn't, because if you're in very sunny conditions, that can affect the function of the panels, which reflects some of the light and some of the heat. And this varnish is made from a chemical substance called gallium arsenide, right? Gallium arsenide. Now, gallium arsenide is not good for you, right? It's not good for you. If you were to have very strict health conditions, as they do in some countries, that would raise the cost of the panels because you would have to put the health and safety conditions so the workers there wasn't any toxicity from the gallium arsenide. But part of the reason why these solar panels are cheap is simply because the health and safety regulations are not in place to make them. So even with something like solar panels, which is environmentally good, there is some kind of social cost. You don't get something for nothing, and this is the important lesson of Paris. You don't get something for nothing. You always have to take into account the social cost in any scientific development. So to finish, what is it about critical realism and its philosophy behind Paris? First of all, rather than just talk about nuclear reactions and what they do, we would ask the question, our knowledge of nuclear reactions explains their power to destroy all organic life. We need to know about these things, the science. Therefore, we can understand how to organize to prevent such an action. In other words, our scientific knowledge should help us to stop the kind of events which would obviously destroy the planet. And finally, we go towards a solution because we can say, as humans, we have certain inbuilt needs and capacities. And science, not just science, but artistic insight and the humanities can say what human well-being might look like. That's why multidisciplinary curriculum is something that's crucial for us to think about. And if one can demonstrate a systematic connection between inaccurate beliefs and oppressive social structures, then one has not only explained the beliefs, but shown a way to change the social structures. In other words, this knowledge helps us to think of actors and how we can change and how we can ameliorate these conditions. In other words, our knowledge and understanding of science are intimately connected, that we can find this connection between our happy use of the mobile phone and the conditions of production. And I know there's a quote from Karl Marx in there, but I put it in to be troublesome but the philosophers have only interpreted the world in various ways. The point is to change it, right? The point is, and this is what central action behind this. I just want to end with this symbol. Coca-Cola. This is part of the thing which I talk about the Trojan horse. Coca-Cola manufacturers obviously think Coca-Cola is wonderful, right? It's great drink. So all over the world. Never mind it does things to our teeth, but Coca-Cola is great. This is the sustainability framework from Coca-Cola. Can you believe it? Coca-Cola has a sustainability framework. The world, they're almost critical realists, these Coca-Cola manufacturers. And the thing we need to do is to learn to read these symbols, to understand how things are projected to us, so we can understand what's beneath it. The surface of Coca-Cola is, our sustainability framework. I was reading the other day, a low-cost airline is saying we're benefiting the planet, right? By flying more, we're benefiting the planet because we're using fuels which don't use so much carbon. We're not using so much carbon. Well, just don't use them at all. This is the question. So how these things are presented, we need to understand as scientists and as thinkers beyond science how these things affect us. I'll just end there. Obrigado. Use that.
Can I use this?
Yes, fine.
Se ajuda. Ok, então a gente tem agora espaço para as perguntas. A Sandra vai ajudar. Lembra que tem gente assistindo, então a gente vai pedir para que as pessoas perguntem aqui. Ninguém precisa fazer a pergunta em inglês, tá? Pode fazer em português, que aí alguém traduz. Eu vou sentar aqui só porque tem o microfone preso aqui. Quem começa sempre duro começar, né? Who will be the first?
Yeah. Well, people sometimes need time to think.
Let me start with a very broad question. How a teacher that was the primary and secondary teacher that was involved in Paris project feel, how they reacted, how was a little bit the perception of?
Yeah, very, very good point. Actually, Paris was aimed at teacher educators, but nonetheless, I should have said that, but nonetheless, of course, it's to transmit that to teachers, for teachers to understand that. As I said, a lot of science teachers, particularly in the UK, and let me just explain very briefly that in the UK it's slightly different from Brazil. Most of our science teachers do a science degree at university in physics, chemistry, or biology, or other science-related subjects for 3 years as undergraduates. Then they do a 1-year postgraduate course to become a teacher, to learn to be a teacher. So they don't start off doing teacher training courses. They do science and then learn to be a teacher. And therefore, they feel their real expertise is talking about things like oxidation and gravity. They feel comfortable with that. When you say, talk about socio-scientific issues, they say, well, and quite understandably, they say, it's difficult. We're good at the science, but please, just let us teach us science. Let sociologists do that stuff. We'll just do the science. And this is very understandable point of view. But what we try to make clear is how you can actually really understand the science more by bringing in the social issues. In other words, the social and political and economic issues actually enhance your understanding. Let me give 2 very simple examples from, let's take the example of you're teaching hydroelectricity, right? Teaching hydroelectricity is very simple in school, hydroelectricity. You teach hydroelectricity is a form almost of, we talk about renewable energy. We don't need to use fossil fuels. And indeed, some of the big companies say hydroelectric power is a clean form of energy. But what do we mean by clean? Well, let's think about it. For hydroelectric power to work, first of all, you need water, and you need water to fall from a height. So you need to understand things like potential energy, water flow, the conversion of the wheel, the wheel that goes round into electric energy transfer conditions. So you need to understand about height, potential energy, kinetic energy, transfer of energy with the pellet wheel. But what does this actually mean then? For hydroelectricity to work, you need areas where there are high mountains of water, right? In other words, you need areas which are really physically very beautiful, wilderness areas. So you need mountains and you need water. So first question is about hydroelectricity is to think about it, that you need places where you can build dams, where there's lots of water, where there's height and where there are rivers. Now, once students understand this, the ideas behind hydroelectricity become much clearer to them. Now, as you get energy transfer, as water falls and the energy is transferred, it becomes warmer. Now remember, fish are cold-blooded creatures. So as the water becomes warmer, the fish will die because they're not used to, they can't adapt to those higher temperatures. So we can learn about the benefits of hydroelectricity, but if we understand its social cost, how it works and how it works, we can actually understand the principles in greater depth. We can understand what they mean. Another example was a very wonderful student teacher I had, who was probably the best. I've had some fantastic student teachers, but she was the best. And she did a lesson, and the thing is to start small. Don't try and do huge projects. Just do small things. You can do maybe even a lesson like about hydroelectricity. But this teacher was doing something on food webs. And she brought in a very simple thing. She said, well, we're going to make a food web. And she gave the students strings. And the strings were representing flows of energy. So you had to think, where was energy flowing from to whom? So you had things like foxes, people, trees, caterpillars, and so on. And everybody was designated had a different animal or plant, and they had to find out where the connections were. And this was for 12 or 13-year-old students. And during the lesson, one of the children just opened her eyes wide and said, yes, does that mean we're all interconnected? Does that mean we're all connected with each other? And the surprise to her that there was this connectivity was enormous. And then the question discussed about how we are connected to each other, how our food doesn't just come from a supermarket. We have to think about the sources of food and how they're interconnected and why energy flows are important and why they work in certain ways. And I would say that's also a Paris-type lesson because it's introducing an element of thinking about the social context behind the scientific ideas. So they can be very small, they can be large projects, but we advise teachers to start with very small things, which they can do maybe in 5 or 10 minutes, and then expand out if they feel comfortable.
Daniela.
Thank you very much for your talk. And continue Mauricio's questions. Mm-hmm. I'm curious about the relationship between the official and the regular curriculum mm-hmm. and the project, because it's something that is more than the curricular mm-hmm. and extra, mm-hmm. or do you believe it's possible to include and to integrate to the regular curriculum in the basic school?
The answer to your question is very simple. C. Yes. Yes. And as I've explained in, for example, in hydroelectricity, that actually you can teach that in the same time as just teaching the concepts. But if you teach about the social consequences, actually you find that students remember, they integrate it more into their thinking about it. And it doesn't take much extra time. In fact, you can easily do it within the time allotted. Yeah. How is it in London? Or the UK? London, there is a bigger country.
UK, sorry.
How is it in the UK?
Sorry. But how it works? Is it working in the UK? Because here we have a very difficult thing to introduce and to integrate into the regular curriculum, into the instructional materials.
Absolutely. I completely agree with you. There is a word in English we use called satisfice. And it's actually an engineering term originally, but it's a term which means if you can't make a perfect system, you can make a perfect system to work as good as it can, but you can't make it perfect. And I think that's the idea to use. You're not going to convert all the teachers or all the curriculum, because we have a very traditional curriculum now in the UK. But you have to go, and this is the way we've found to do it. Go with the teachers who are enthusiastic. In every school, you will find an enthusiastic teacher. And an enthusiastic teacher will teach it hopefully well. So within the time, will show that you don't need too much extra time. And that enthusiastic teacher will disseminate to the other teachers in the school and will gradually convince them, persuade them of how to do it. They're not going to persuade every teacher. And indeed, there are some very good teachers who hate teaching about, and that's fine. But there are some teachers who really find that this can improve the way they think about things. And I've done this now quite a lot. I've done things, for example, on aluminium, the extraction of aluminium, and shown how you can just learn the formulae. But actually, if you understand, for instance, how aluminium is extracted, what the cost in fuels is of extracting the aluminium, how we dissolve the aluminium, because it's difficult to dissolve the mineral in water, how do we actually dissolve it? Once they see all these things and the social consequences, the students actually say, now we're understanding it. We actually understand, not only do we understand the science concepts, but we actually understand what they mean. And so in some ways we've had great success with teachers being able to take it on and do it. And in some ways we've had teachers who say, it's not for us, and we can't incorporate it in the curriculum. But our message is you can incorporate it in the curriculum. And if you feel comfortable about that and you have the support, absolutely do it. But we recognize that, like anything, you have to say you can't do everything. You've got to do what you can.
Posso fazer em português? Okay. Tá. Você que vai traduzir, Maurício? Tudo bem, é que eu estou fazendo em português porque eu acho que nem eu estou entendendo a pergunta, então eu vou tentar construir.
Yeah.
Eu queria, na verdade, a gente vem discutindo no nosso grupo um pouco esse papel do conhecimento e da ação, né? E aí eu queria problematizar um pouco essa questão do papel da ação e da disposição na tua apresentação. Concordo com as críticas que você faz em relação a como o professor pensa o conteúdo, mas minha questão é que como não cair em certas versões muito simplificadas da ação. Então, eu vou dar um exemplo. Você descobre que o nióbio, na verdade, vem das minas do Congo, e você fala assim, bom, então eu não vou usar o celular. Isso, na maioria das vezes, traz para a pessoa uma ação em relação àquele conhecimento que resolve o problema da consciência individual, mas não resolve o problema ainda como um todo. E o que eu vejo, às vezes, se estruturando é um pouco disso. Como que individualmente eu posso agir, dado que eu tenho aquele conteúdo, mas ele só desaparece da minha consciência, porque agora eu posso dizer que eu não sou mais o causador, digamos assim, daquele sofrimento. Não sei, estou falando muito rápido ou não?
Yeah.
Yeah. Starting to say that we agree with your picture of the research, but they had a group of research that was very interested in the relation between action and knowledge. And the main question that that there is some kind of oversimplification of the idea to act, in the sense that they give you
quick solutions. Yeah, absolutely.
And one of the examples that they propose is that, for example, the case of the niobium and the
tantalum.
Cell phone.
The cell phone.
For
Yeah,
example,
yeah.
When you present to the students that you need the niobium came from this area of Serra Leone, and it made very problems there, I decided to myself don't have a cell phone. Means that I solve the problem in a personal dimension. And it's more to save my conscience.
Absolutely.
And say, no, I am no part of this.
Absolutely.
But how we can make a little bit, because the problem is a little bit more complex
absolutely.
than just putting myself to avoid the same.
Yeah, completely agree. And let me just even add to that one of the benefits actually is that cell phones are sold very, very cheaply in East Africa, much more cheaply than in the West. So a lot of people, East African people living in East Africa, can use cell phones at a very, very cheap rate. So there actually are real benefits for the local population through this. And you're absolutely right. I don't want to say, oh, look, there's a problem, let's not ever use cell phones. But we need to use them. I mean, they're a fact of life now. You know, I have a cell phone. We need in our world, we can't do without them. What I think is when we talked about critical citizenship, and I mean to understand that no action is so simple that there's no complexity with it. And the point I would make, even about the cell phones, I didn't manage to make it here because I wanted to show the material relations, is that actually it's complex because actually the local population in East Africa actually benefit by this form of oppression. And if we think, and I think one of the things that Paris has done is not to make students think there's a simple way to solve a problem, but that actually there's always complexity. We have to think very carefully about our actions. So not to immediately throw away our cell phones because we're disgusted by it, but to think, yes, we need our cell phones, but what does it need to be done to produce cell phones in a way that's more socially just? What can we do? And you're not going to change the world overnight, but maybe by increasing people's consciousness about these things, you are enacting some change. And I agree, I would never, and even, when measuring the heat change in schools, what students realized is the difficulty of making the measurements, that it wasn't an easy thing to do, nor was it an easy thing to solve the problem. But by understanding that, they could actually act in a way which was much more effective, not to say, oh, great, here is the answer. So I should add, yes, I mean, we want to make the complexity of these issues, more important. I agree completely. Because
aproveitem para que eles possam trazer mais. O pessoal só perguntou da banda da esquerda. Da direita para vocês, da esquerda não perguntou. Eu tenho um monte de perguntas aqui, mas não quero pegar assim. Agora. Se puder fazer mais curtinho.
Mais curto, mais curto.
That's all right. Mais curto. Okay. Sometimes people need to think, some people...
Na verdade, é difícil porque eu ainda estou elaborando o problema, né? Que é ainda no mesmo campo, né, da ação, um problema que aparece para o professor, né, porque, por exemplo, anteontem, né, eu estava discutindo com a minha esposa, que é advogada no setor elétrico, e ela estava me explicando por que os chineses estão comprando a nossa energia, né? Então, a CPFL, por exemplo, hoje é chinesa, uma estatal chinesa, e eu fiquei curioso. Ela falou assim, olha, tem um detalhe que é os chineses exigem um tire pequeno. O que é isso? É o retorno esperado da coisa. Então, eles conseguem comprar porque eles estão com retorno esperado de 2%, enquanto o americano, o europeu, precisa ter um retorno esperado de 5%. Eu, na verdade, estava curioso para saber do problema energético e tal, mas você vê que o problema, eventualmente, vai para conteúdos específicos, por exemplo, de economia, ou de como a coisa está. E aí, como é que o professor de ciências age em relação a isso, sem também cair numa versão, às vezes, ou até ingênua do processo econômico? Eu estou dando um exemplo de um conceito muito específico ali que eu não sabia, que faz toda a diferença, mas eu imagino que isso seja um problema rotineiro para o professor, né?
He wants to remain in the area of action.
Mm-hmm. Mm-hmm.
And he related, I noticed a conversation he had with his wife.
Mm-hmm.
He's a lawyer in the area of electricity.
Mm-hmm.
And they are discussing about how the Chinese could arrive to Brazil and buy many of the electric distributions and power of productions.
Mm-hmm.
And he expected that the discussion could bring some special nature of the scientific concepts, but in fact, the aspect that determine why the Chinese has more success than the others is because the
expected rated return.
The return of
the profits, profits,
investment was lower than the others.
Yeah.
It means that normally they arrived with an expectation of 2%, and the American and European company had to have
a higher return.
He noticed that the question sometimes is that if you overmiss, it means that if you have just a superficial understanding of the complexity of the situation, you can pass to the students a not simplified version. And because sometimes you have to know very
absolutely
for that reason, for that example, if you don't understand the economics, this aspect of economics, you cannot understand this kind of problems. And in the same sense, is that possible for a teacher to not be a naive presentation of such kind of complex problems? This is the question.
Yeah, right. And it goes back to what I was saying before. I mean, yes, you're right. And in fact, it's primarily an economic question. And we actually have a situation in Britain where actually our nuclear power stations have been bought by one very important source of nuclear power, has been bought by Chinese-French consortium. And of course, to find out the reasons, I mean, politically there's a question because it says a lot of our power, of our energy sources are in the hands of people who are not responsible to us. And of course, there's a great deal of complexity in these questions. But all these questions are complex. The point of Paris, me taking the example of a cell phone, for example, was was actually to say, we have the cell phones on the surface, but we need to think more deeply about where these cell phones come from and what's involved. Now, you're absolutely right. We even need to think more deeply than that. Once we know the conditions, we need to think why those conditions arise. Maybe there are benefits for people working in those conditions. Economics, the political world is extremely complex. And I would say the point of Paris is not to simplify, to say there are simple answers to these questions, but actually just to begin to outline the complexity. And I think a responsible teacher would say there are no quick solutions to these problems, but actually we do have to start thinking about them at a certain level. So, you know, the teacher who says, when the principal of the school said, convince me that we should take away the dispensing machine, he was saying to the kids, it's complex. There's a social benefit of that fizzy drink machine, but how can we raise the same money without doing less damage? Now, even then, there are students who might say, well, soft drinks are also bad for you. You know, that non-fizzy drinks are also bad for you. And that raises another type of question. So I don't think the answer is to say, oh, there's one solution, but can we think of ways of making it better? And that's how the world works. The world works not by saying, oh, there is the solution, but there is a solution to a problem which raises other questions. And that's why we have a circular thing in our diagram, that we've found a solution, but that raises other questions which come from it. So I would say, if anything, a teacher who's teaching is, and I would argue about the hydroelectricity, that the arguments about teaching the hydroelectricity do raise the questions of, if companies say this is a clean product, it does help us to think about what do we mean by clean. It doesn't mean we should get rid of hydroelectricity, but we should understand more the complexity of it. And I think for a critical society, that's absolutely crucial, not to think there are quick solutions, but that there is always a complexity involved. There's always that complexity involved.
Fazer em português também. Aí você faz favor de traduzir, Maurício. A minha pergunta, muito dado no exemplo que ele deu, né, a consciência que ele tem do problema, né, no caso da hidrelétrica, dos chineses e tal, é porque ele conversou com uma pessoa que estava envolvida no outro tipo de atividade, né? E a minha pergunta é se o professor, né, para encarar esse tipo de problema, ele deveria trabalhar sozinho também, ou se ele deveria ter ajuda de outros profissionais, e como criar um espaço para essas vozes diversas, né? E como ele faz isso no projeto dele.
Ricardo, take the question from André about the Chinese and buying electricity, and say that the point of the complexity was bring by someone that is from another area, in the case of a lawyer, that understand a little bit how the system works.
Absolutely, yeah.
And if you think about this kind of analysis of situation happening in the schools, we have to suppose that the teacher may have some kind of help or support of others. Means that they have to work not alone, but in
absolutely, yeah.
And in the case of the Paris project, how was the way the teacher worked?
Yeah.
Alone or in kind of
with others, multidisciplinary way. Yeah, that's a really good point. This is a really interesting point, because there were 17 countries involved in Paris. And some countries were very much science is apart from everything else. And in other countries, for example, the Netherlands, there was a much more integrated approach to the curriculum. So in some countries, it was actually relatively easy to get people, teachers, to discuss a problem, discuss how they're going to bring different expertise to it and have a, do something about it. In some countries, I remember in Portugal, there was a wonderful project on antibiotics, run on antibiotics, where the teacher really got into the science, wasn't attempting to really address other problems, but just to look at how the science can have meaning, how our understanding of it might have social effects. So in other words, to deepen the students' understanding so they could think about these questions maybe with each other. So that was a very different way of approaching it, of maybe raising questions for students to think about. But the staff, the teachers weren't there to really take it further. In the Netherlands, it was much easier to bring teachers together. In the UK, it's almost impossible in some schools. Even in some schools, we get science departments, geography departments, history departments. They sit in different rooms and they don't even speak to each other. And sometimes they don't even know that the other teachers exist. So it's very difficult to get a multidisciplinary approach. Some schools do. Some schools are very good at saying we have to make children think about these things, but not to make it simplistic. And other schools, it's much more difficult. But I'd bring you back to the example of the young teacher teaching with the food webs, that actually, although she was teaching totally about scientific ideas, it raised questions about connectivity. It really made students think about, well, actually, we have a broader responsibility if all our needs are interconnected with the living world. If we destroy part of the living world, then that will affect us ecologically and environmentally. That doesn't mean they immediately went out on the streets and said, we've got to save the world. It meant that they would go home, they would discuss it with their siblings, with their family. When they heard news about it, they would have deeper ideas about it. And sometimes, I have to say, students didn't change their minds, and that was fine. They thought about things and said, no, we're not going to change things. But I think your point about multidisciplinarity is it depends where, and I would say if you've got the conditions to do it, fine, and you can do quite big projects. If you don't, then we have very small projects you can do without necessarily needing to to measure too much different disciplines.
Hello, I'll try to make the question in English. I don't mean to diverge too much from the topics, but there were questions about the curriculum, and I wanted to know, you mentioned about the graduation structure for teachers in UK, and I wanted to know more about your opinion about this, since about, just a moment, let me think. Do you think it would be the case to just add this discussion in the already existing courses, or to change completely the curriculum they have today?
But the curriculum for students or
for teachers?
For teachers.
Yes. Do you think it's a okay structure, or do you think a course, a teacher formation focused on teaching would be more adequate?
Yeah. Again, our teaching curriculum is very much directed towards what we say competencies, to show the teacher is competent in teaching in a certain way. And these skills are broken down a lot. And generally, to best meet these competencies, teachers feel most at home in the very, I would say, curriculum where we teach about atomic theory only. So they learn atomic theory and never mind the social context. So that is difficult to change. And I don't pretend this is simple. But the problem is, I think, that we have many teachers, some teachers who really don't know, and I think about this sometimes, don't really know much science. I mean, they've got science degrees, but they actually are unable to think about the science. And in that case, that's transmitted to the pupils. So the teachers teach what they're comfortable with. And that's the way the teaching curriculum broadly works at the moment. And then when a student asks a difficult question, we become, oh my God, well, I don't know. I've never thought about that before. And for example, let me give you an example of the kind of thing we do to make. So when we interview teachers, one of the questions I ask, for example, is how would we know if we were living in the early 19th century and before, how would we know the world was round? Yeah, how would we know the world was round? And they say, well, we go in space rockets and we can see that. I said, no, you didn't have space rockets. How would you know if the world was round? And these are physicists, right? These are physicists. So they say, I've never actually thought about it. I don't know. And we often ask them very simple questions, and they find it difficult to use their science to answer the question. And I think what happens, I think the teaching curriculum, I think if we made teachers think a little bit more about the problems, then I would argue they would be better teachers. But the timing doesn't really allow that, to happen. And if I can just give you an example, again, if I can give you an example about this isn't about teachers, but it could be about teachers. I was doing a project in chemistry with a chemistry colleague. And the question was, when students learn, I don't know if any of you are chemists, but when they learn about chemical equilibrium, there's a certain principle called Le Chatelier's principle, which if you know the algorithm, you can apply the algorithm you can apply the algorithm to the question. And examinations ask you about the algorithm. And we set the question to 200 students who were studying chemistry at an advanced level, where they couldn't use the algorithm. So the question was about chemical equilibrium, but they couldn't use the algorithm. And of the 200 students, only 7 could actually answer the question, even though they got, some had got very high marks in exams. And when we found out who were the 7 who could answer the question, 5 of them were boys who regularly got very low marks in chemistry, very low marks. And we said to the teachers, these 5 boys got low marks, but actually their understanding was far better than those who got high marks. And they said, we know they're very bright, but they're hopeless at doing exams. And we gave them an exam question. And what they said is, when we said, just answer this exam, talk us through it. And it was a very simple question. And they said, the world isn't like that. You can't organise the world like that. And they started giving much more complicated answers than were necessary. And what we had to say is, look, this is a way of doing the exams, so you need to learn how to answer exam questions, go directly. But don't stop thinking about the understanding. So your exams are over here, your learning is over there. Keep on the learning because you will make really good researchers and scientists. But when you do exams, for goodness sake, just answer the question in the simple way. And I think that's what teachers have found problematic, because they've been taught to answer exam questions very well, to answer exam questions very well. But when they come to teach it, they suddenly find the students, a bright student might ask a difficult question, they'll say, I don't know. And the problem with our curriculum is it doesn't really help teachers to do that kind of thing. So you get a circular process. But what we try and do as teacher educators is to subvert the process, to be a bit revolutionary, and to give them these difficult things to think about in the classroom, and then take it back, and then use it to expand the way they teach. So, sorry, this is a long way of answering your question. We do have a curriculum which is very tight for teachers and very straightforward, and it helps them function to meet the competencies. But as teacher educators, we have to take that curriculum and try and enrich it and try to get them to think more deeply about the curriculum so they can address these kind of questions. And I think that's the best we can do. We do live in a world where it's ruled by performance, by how you do in exams, how you perform in the classroom according to certain levels. And I have to say, just to finish on this, I once had a student teacher who I thought was brilliant, was wonderful. And when I came to the school said, he's hopeless, he can't be a teacher. And I said, okay, I'm surprised because he plans very well, he's very knowledgeable, he's very thoughtful. Maybe he's not very good in the classroom. And I saw the lesson, and it was a completely brilliant lesson on teaching about the structure of the earth. And he was teaching about the earth, and he was saying, he was teaching students that the earth, because a lot of kids thought the earth was just solid. And he was saying, no, he was helping them to understand it's on a liquid layer, it fractures, you have earthquakes. And I heard one student going out the class, a 12-year-old boy, and saying, I thought it was just rock down there, but it's a very thin thing we live on. Right? It was brilliant. And the teacher, the supervising teacher, came to me at the end of the lesson and said, you see the problem we've got with him? No. No. Well, where's the problem? And he said, no, in England we have a thing, you have to write the objectives of the lesson, what you will learn on the board at the beginning of the lesson. And he didn't do that, right? He didn't function that way. And she said, you have to do that. The kids are used to that. If you don't do that, they won't understand, even though they did understand. So I said, I discussed it with him, and I said, well, why didn't you write them on the board? It's quite a simple thing to do. And he said to me something so profound at that point, I hadn't thought about it. He said, I know what I'm going to teach in this lesson, I do know, but I don't know what they're going to learn. So how can I write what they're going to learn on the board? And I thought, of course, you're right. Of course I'm right about that. So I said to him, look, you're brilliant. Carry on doing what you're doing. But for goodness sake, just write those things on the board because it will keep people happy. And I think you've got to learn to work with the system. It's not perfect. It's terrible in many ways, but you've got to learn to work with it.
I will try in English.
Yeah.
Congratulations for your presentation. I like it very much. I work with critical environmental education. Luiz Marcelo.
Yeah.
And we have connection with your perspective, because the environment is an object of transformation, of emancipation. Then we work with Paulo Freire thing. In London, the Paulo Freire is used.
Yeah. So Paulo Freire, yeah. Paulo Freire, I think Paulo Freire has obviously in Brazil and probably Latin America a very important role to play. Not so much in the UK. I would say certainly people have heard of Paulo Freire, the pedagogy of the oppressed, have heard and discussed Freire. But there are also other things. I mean, John Dewey, for example. John Dewey has a very important role in thinking about education in the UK. The constructivist school, which I have some problems with, also has a very important role. Freire has probably less of a role, although I would say the more socially conscious teachers, more critical teachers, do have an understanding and have read Freire. Actually, I think there are also we have a group that does discuss educators like Freire, but also Jacques Rancière, who is a very interesting French educator, who I think is really interesting. And many of, like Sylvia Wynter, many of the radical American educators. But certainly in central theory in science and even in environmental education in the UK, I don't think Freire has the role he should have. And that's possibly because of the different material conditions in the UK compared with Latin America, for example, where, the liberation movement, the social liberation movement is probably much stronger. But certainly Freire is known. And in fact, there are critiques of Freire, there have been critiques of changing consciousness. What does it mean to change consciousness? Is power involved in changing consciousness? Yeah. Anyway, so I think Freire is very much respected, but there are also critiques of Freire, and the problem, think of the teacher-student relationships of power, of what it means to change consciousness, that kind of thing. Yeah.
And the other question.
Yeah.
You work with sustainable goals of UNESCO. You work with 17 sustainable environmental by UNESCO.
What is the question?
17
yeah.
Part of your goals in the Paris project, or not connected?
Not explicitly, no. And I think the problem in the UK is that environmental education, global education, sustainability, is what's called, and this is an issue, is a cross-disciplinary subject. So it's supposed to be taught not only in science, but in mathematics, in geography, in history, in literature, and so on. And the problem is, again, that science teachers want to teach science, and they don't necessarily know very much about sustainability. So effectively, the other problem is cross-disciplinary subjects aren't examined. They aren't examined. So teachers tend to ignore them. And what we have to do is take the UNESCO framework, and can be quite critical of that framework as well. We have to take the UNESCO framework and say, what are the principles within that framework that, say, science teachers can work with maybe in the Paris project? So we have to take note of these, but rather than say you have to teach this, so to give them a context in which they can elaborate it and teach it, possibly.
So I'm kind of running out of time, but my question is a concern that I have about the approach, because how much we can let our students have an outcome of these questions that goes against human rights.
Mm-hmm.
A lot of the subjects touch in this area, and making a decision for the question like doing nothing,
Mm-hmm. Mm-hmm.
it's going against human rights, because when you understand the chain of your action, how can we really, as teachers, deal with this in the class? Like how we deal with this controversy of the outcome. Can we choose to do nothing? You know?
Yeah. That's a really good point. And there is a risk. It's a risk that students will learn about something. They may learn about how their cell phones are produced and all the complex reasons of how their cell phones are produced, and say, what can we do? We're powerless to do something about it. And actually, I know this doesn't sound, but if you take a decision not to do something, but you know more about it, you actually feel more informed in your consciousness, but you realize there's a limited amount that you can do, then in a way, to change consciousness is an action. To change consciousness is an action, because people whose consciousness is changed it won't be quick, will talk to other people. And maybe locally, politically, ideas will begin to diffuse. You can't change the world overnight, but you can open people's way of thinking about things. And I think an important aspect of education is to problematize and is to see complexity where before we could only see simple solutions, is to see that. And that's part of the reason why in the early part of the work I was talking about people like Darwin and Newton, is we need to understand science has also developed problematically, that science itself is not a uniform construction, that there are different ways in which scientists think about things. So I agree, and let me say, you can even have a bigger problem, because I remember many years ago a teacher teaching about eugenics. Eugenics is where the philosophy of eugenics is we should breed people for an intelligent population of people who can be more intelligent. Eugenic theory was very prominent even among left-wing ideologists in the early part of the 20th century. We need a society, we need to have good people, strong, active, intelligent people. And if they're not intelligent, we should basically not have them. And the teacher I was working with a group of pupils, and one of the pupils said, after learning about this, said, yeah, that's right, we should just get rid of, And that was, to think in that way was, oh my God, what have we done? And I think that's why you have to be really careful, why I think critical education is crucial, to think about how you're going to handle these issues. But I don't think teachers can raise consciousness and complexity and discuss ways to think about acting about things, but we don't live in an authoritarian society. We live in a society, hopefully, where we can discuss and deepen thinking, and we can open up ways of action, but we can't tell people how to act. And I think that is an issue, and I don't think there's a simple answer to it. But I agree with you. I think your question is, we can open up human rights issues and then say, well, what can we can do? But if I discuss, the complexity of making cell phones, and then you discuss that with a friend, and you say, well, we need cell phones, but we know it's horrible. And then you find out, well, actually, cell phones do enable communication, even amongst depressed people. But what can we do about things? And then it starts up a conversation. And I think one thing, sorry, Justin, I know this long answer. I think one thing we've got to be very careful of. I assume most of us here live in a relatively privileged society. We don't, broadly we have access to education. We don't live in conditions which many people do live in, which are terrible, terrible conditions. And I think we've got to be very careful of saying, this is what we should do for people we know very little about. But we can raise questions about that, and we can discuss it, and we can say, what does it mean for us? And I'm very much against, I really almost hate it, when you get what I call do-gooders who think, I'm going to change things because I think this is horrible, without really understanding the complexity of what's involved. But I think our role as teachers is to educate, and to educate is to bring out all the factors which we understand to influence how things are taught.
Acho que é hora da gente encerrar. Ah, tem mais uma pergunta? Desculpa.
Thanks,
The last one.
Thanks,
I'll try to be
Mr.
short as well.
Thanks, Mr. Livingstone. I have a question. Is the Paris project? We can involve social and political and economic aspects. For example, how to Brexit can affect the metallurgical and the textile industry in the UK.
How can Brexit affect this?
Yes. No. Is in the Paris project, we can involve the aspect economics and socials, kind of metallurgical and textile industry in UK, and eu vou tentar em português.
In Brexit, yeah.
Se o projeto do Paris ele pode abordar aspectos sociais e econômicos, como a saída do Reino Unido pode afetar a indústria metalúrgica e têxtil na Inglaterra.
Brexit, the question of Brexit. Right. I haven't specifically thought about Brexit in this context, but yet you made me think about things. So yes, there is, I think, immediately of certain things. So, for example, the Americans see this as an opportunity to sell meat, more meat products to the UK. But it seems from what I understand of the news that the way in which meat is treated in the US, the regulations are much lower than they are for the European community. So it raises a public question about if leaving Brexit means that we're exposed to food, to meat, which is of a lower quality, health quality. What should we do? So you really need to understand at the first, well, what is involved? What does it mean with the way, say, the Americans treat meat, which is apparently in chlorinated products? Will that really make things worse for us? What is happening? And so I understand, so to deal with that question, I would say to some extent, you need to understand some of the science. You need to actually understand, well, what does chlorine do to meat? What does it do to preserve it, and so on? And if you don't have that understanding, you're powerless. You really can't think very much about that question. Another question is medication. We rely on medication. I rely on it because I have to take some medication from Europe, and we're told that medication may not be available to us. Well, what does that mean? Now, that's not strictly, I mean, to be honest, if you've got a problem with your heart and you can't get proper heart pills, you don't need to know much science about the heart. You need to think, oh my God, where can I get that medication from? So there are different kinds of questions. So I would say the idea of chlorinated meat does open itself for students to think about, well, what does happen to meat when it's treated in that way, and does it happen to health? With the question of medication, you probably don't need to know that much about medication. You just need to know, I need those pills. How can I get hold of them? So it depends to some extent on the context of the question. And I'm not saying that every socio-scientific question, you do need to know a lot of deep science. I'm really not saying that. You need to, but you probably need to know enough science to actually help you think about the question in a way that makes sense to it. But I'll have to start thinking about Brexit. I haven't really thought about that, Paris.
Ok, então acho que é a hora da gente agradecer. Foi muito boa as questões. Só agradecer ao professor Ralph. Só para que vocês saibam, as fotos e o vídeo, né, que foi gravado e transmitido ao vivo, eles vão estar disponíveis no site do IEA, provavelmente em 10 dias. Então, se vocês quiserem eventualmente divulgar ou convidar alguém para assistir, é possível. Ele vai ficar disponível supostamente, eternamente, no site do EA daqui a 10 dias. Tá bom? Então, muito obrigado a todos, tá? Boa tarde e bom fim de semana para aqueles que a gente não vê mais. Thank you. Thank you, Rafa. Thank you very much.